Hello everyone, Dr. Polaris here. During the late Cretaceous, the rich seaways of the northern hemisphere were home to the Hesperornithes, a group of often large and flightless ornithurines that were closely related to modern birds. With some species being comparable in size to adult humans, these foot-propelled divers filled niches similar to living flightless seabirds and pinnipeds. However, despite their diversity and ability to live in a range of different climatic conditions, from tropical to subarctic, the specialised Hesperornithes died out during the KPG extinction event 66 million years ago. During the following Paleocene period, the Neornithine birds underwent a dramatic radiation due to the extinction of all other avialans, with early members of the penguin lineage Sphenisciforms emerging in the southern hemisphere and filling similar niches to the extinct Hesperornithes. Some of these early penguins also developed notably larger body sizes than their living relatives, again being similar to the vanished Cretaceous ornithurines. Meanwhile, the seas of the northern hemisphere would be devoid of any large flightless marine birds until the end of the Eocene circa 38 million years ago, when the Plotopterids first appear in the fossil record. Native to the ancient Pacific Rim, with a range stretching from what is now Japan to California, these were large flightless members of the clade Suliforms, which also contains the modern cormorants, anhingas and gannets. The Plotopterids were wing-propelled marine diving birds that displayed notable convergent similarities to the giant penguins that lived on the other side of the world. These included a brain structure that was very similar to those of modern penguins, in addition to comparatively shortened forelimbs well adapted for underwater locomotion. These two groups were, in fact, once thought to have been close relatives, although this is no longer thought to be the case, with Plotopterids having shoulder girdles, forelimbs and sternums that differed markedly from those of penguins. Additionally, the hallocks closely resembled those of frigate birds, indicating that these animals evolved from agile, highly aerial ancestors that eventually traded in the ability to fly for a flightless diving niche. Seemingly evolving in the high Arctic during the Middle Eocene, Plotopterids were inhabitants of the kelp forests that were expanding in range during the late Eocene and Oligocene, with the birds dwelling in these rich ecosystems alongside cetaceans, the superficially hippo-like desmostylians, and eventually the first pinnipeds. At this time, active volcanism around the Pacific Rim led to the creation of many offshore islands, which were ideal locations for seabirds to form breeding colonies away from continental mammalian predators. The oldest and most basal known Plotopterid was the genus Phocavis, from the late Eocene of Oregon. With a name meaning seal bird, this animal was native to the Kesey Formation, which represents the remains of deep sea deposits formed at depths of between 500 and 1,000 metres, hinting that Plotopterids were able to venture far from coastal areas at an early stage in their evolution. Interestingly, another basal form, Plotopterum, was among the youngest members of the family as well as being the smallest, roughly comparable to a modern great cormorant in size. Endemic to California and Japan from the late Oligocene to the early Miocene circa 16 million years ago, Plotopterum retained basal skeletal features and was not as well adapted for wing-propelled diving as the older and larger Oligocene genera were. This relatively unspecialised coast-dwelling niche may have allowed Plotopterum and its late Oligocene close relative Stemec to hold out while other members of the group were becoming extinct. All of the more derived Plotopterids were classified within the subfamily Tonsalinae, with the most basal of these being the genus Tonsala itself, from the late Oligocene of Japan and the US state of Washington. Proficient divers, these animals were similar in size to the modern king penguin. The largest North American Plotopterid, meanwhile, was the genus Clalamornis of late Eocene and Oligocene Washington, specifically the species K. clarki, which was roughly comparable to the living emperor penguin in size. However, the most massive and well-preserved members of the family were endemic to Japan, including the genus Hokkaidonis, which was unsurprisingly native to Hokkaido during the late Oligocene. Unlike most Plotopterids, which are represented by pretty scrappy remains, Hokkaidonis is known from a near-complete specimen that only lacked a skull, giving paleontologists a better understanding of its life appearance. The genus stood about 1.3 metres or 4.3 feet tall, and would have possessed a relatively long neck that was not obscured by body fat as in modern cold-adapted penguins. giving the bird a more slender and less rotund appearance. The tarsometatarsal bones of the hind legs also had prominent muscle attachment points, which indicates that Hokaidornis was able to propel itself through the water by utilising its hind feet as well as its forelimbs. Meanwhile, the most famous member of this underrated family of seabirds was the genus Copipteryx, which I initially assumed to have been named after Edward Drinker Cope, although its name actually derives from Greek and means oar-wing. Two species of this animal were endemic to Japan during the Oligocene, with the smaller of the pair being Copipteryx hexeris, which measured about 1.2 metres or 3.9 feet long. The largest species, as well as the most massive Plotopterid, was the huge Copipteryx titan, which measured approximately 2 metres or 6.6 feet long. Additionally, some as yet undescribed remains attributed to this species may indicate specimens of even larger sizes, potentially making sea titan the largest flightless seabird to ever live. Its femur alone was about twice the length of the corresponding bone in an emperor penguin. It's recently been suggested, however, that sea titan may simply represent male individuals of C. hexeris, given that modern cormorants and darters display notable sexual dimorphism. By the end of the Oligocene, all of the large specialised marine Plotopterids had died out, leaving only the small coastal Plotopterum to persist into the Miocene. This genus would survive until circa 16 million years ago, at which point the entire family would fade into extinction. Interestingly, this was at roughly the same time as the disappearance of the Southern Hemisphere giant penguins, with the reasons for this being hard to pin down. However, suggestions have included the loss of offshore islands that these birds utilised as nesting colonies, the warming of the world's oceans during the first half of the Miocene, and the appearance in the North Pacific of the first marine pinnipeds such as Enaliarctos, which may have competed with Plotopterids for food and breeding sites, as well as actively preying on the birds themselves. After this group died out, flightless seabirds would return to the Pacific during the late Miocene in the form of the superficially penguin-like Mancallinae alcids, although sadly these too are now extinct. Thanks for watching, everyone. The next episode will be covering another group of birds with aquatic affinities, with these being the early waterfowl. However, as I explained in my Tylosaurus video, I have now passed my PhD Viva, but in the next few weeks I'll be working on the required corrections, so that I can finally submit my thesis for good. As such, I'll be shifting back to producing videos every 2 weeks, as I need to focus on getting my thesis done, and, secondly, I also need a bit of a break to save me from burnout. I hope that's okay with everyone, and until then I'll see you again soon. Cheerio.